Hello, we are discussing about GATE 1997 ECE paper, and this question is related to analog circuits. Look at the circuit shown, which is a BJT amplifier. If the transistor is biased in forward active region, putting a capacitor across RE, what will happen to voltage gain and input impedance, whether they increase or decrease? That we have to specify in the options. So, effect of capacitor across RE on voltage gain and input impedance is a question. Okay, the right answer for this question is B. So, if you are placing a capacitor across RE which increases the voltage gain and it is decreasing the input impedance, how we will see it? So, now I am going to redraw the same diagram. Okay, and this is the first one is nothing but redrawing the same diagram, second one is with across a capacitor CE. Okay, now after indicating the input terminals base, collector and emitter and necessary voltage VBE, for the first one, that is without CE, we can write output voltage V0 is equal to, V out is nothing but V0 I am taking, V0 is equal to, you can write it as VCE plus IE RE. IE RE is nothing but output expression, V0 is equal to. And if you write the input KVL, that is V input is equal to, V input is nothing but over here, that is VBE plus IERE. So if you observe, IERE is going to be common in the output expression as well as in the input expression. So voltage drop across RE is going to be common for input side as well as output side. So that implies nothing but RE is going to be acting as feedback resistor. RE is going to be acting as feedback, and since it is a resistor, I am saying it as feedback resistor. So voltage drop across this RE is going to be appears in input side KVL as well as in the output side KVL. So whenever there is a feedback element, at that time the feedback can be either of positive feedback or of negative feedback. Okay, now we will see what is meant by whether it is positive feedback or negative feedback. So the definition of positive feedback is nothing but by introducing feedback, if effective input signal is going to be increases, at that time it is called as positive feedback. By introducing feedback, if the effective signal is going to be reduces, at that time that feedback is called as negative feedback. Now we will see what is meant by effective signal for this amplifier. Okay, this is a BJT amplifier. Generally we are in the impression that one, let us assume I am going with the amplifier with gain A is equal to 20. The meaning of gain 20 is nothing but we will be under impression that whatever the input signal, that is source signal, is going to be applying, that will be amplified by 20 times. So V0 can be 20 times of Vs. This is wrong. Amplifier amplifies the input signal with 20. The meaning is that one, but what input signal is important? It is not the applied input signal, it is effective input signal. So V0 is equal to 20 times of V effective, that is effective input signal. So what is meant by this effective input signal? Effective input signal is nothing but input signal appear across base and emitter is going to be called as effective input signal. So this is V effective input signal, VI. V effective input signal. So voltage across base and emitter will be amplified by the gain times. Okay, so it is not the applied voltage, it is only the voltage which appears across base and emitter. Now from this one, if you see, since RE is going to be present, okay, you can write it as VBE is equal to V input minus IERE. So V input is nothing but actual applied input, and applied input subtracting voltage up across RE. So effective input signal VBE is nothing but V effective input signal, which is going to be reducing because of feedback. Effective input signal for the transistor is reducing. So the type of feedback is nothing but negative feedback. Okay. So in negative feedback we know that one. Okay. In negative feedback, the characteristic of negative feedback is nothing but gain reduces. whether the input impedance is going to be increases or decreases with RIF, that is input impedance with feedback. It may be increases or it may be decreases depending on the type of mixing. If it is series mixing, if the input side is series mixing is used, then input impedance with feedback increases. Otherwise, if it is input side is shunt mixing, at that time input impedance with feedback reduces. So now we have to find out whether the mixing type is series or shunt. If we know whether it is series or shunt, at that time we can say input impedance whether it increases or decreases. But irrespective of mixing and sampling, gain is going to be definitely reduces for negative feedback. Okay, so if you introduce negative feedback, gain reduces. Now we will see effect on input impedance because of this negative feedback. So we have to find out whether it is series mixing, shunt mixing. From this input KVL, look at this one. Effective input signal is VBE and applied input voltage is this one. This is feedback. So you can write this equation as V input is equal to V effective input plus VF feedback voltage. So V effective is nothing but V input minus VF. So all parameters across the input are going to be of voltage type, and voltages are going to be subtracted from one another if they are connected in series. Since all the input parameters, that is input parameter, feedback parameter, effective input parameter, all are going to be of voltage type, voltages are going to be gets either added or subtracted if they are connected in series. So the type of mixing used is treated as series mixing. So in series mixing, input impedance with feedback is going to be increases. Input impedance with feedback is increases. So if RE is going to be considered, feedback is present, that implies gain reduces, input impedance increases. Now if you are placing a capacitor over here, look at the second diagram. If a capacitor is placed over here, for AC, capacitor act as short circuit. We will assume that when this external capacitor is going to be enough such that it is going to be acting as short circuit for mid frequency range. So short circuit implies nothing but whose reactance is going to be 0. So the parallel combination across emitter is nothing but RE parallel with XCE. So this will be treated as 0. So that implies nothing but emitter is directly connected to ground. Emitter is directly connected to ground. So now if you write input voltage V in input side KVL, directly V input is equal to VBE, directly you can write V input is equal to VBE, V naught is equal to VCE. There is no common voltage because the resistance of RE is suppressed with the help of CE. Since CE is present, effect of RE is neglected. So no feedback. If you place capacitor, there will be no feedback in this BJT amplifier. Whenever there is no feedback, compared to feedback, gain is going to be increases, and input impedance is going to be reduces. Because by using negative feedback, gain reduces, input impedance with feedback is going to be increases. So opposite takes place if you are removing the feedback. So gain increases, RI reduces. So the right answer is B for this problem, which increases the voltage gain and decreases the input impedance. Thank you.